let's continue our lesson for today. In our previous lesson, we have discussed the basic of how to describe motion in kinematics. We have discussed the difference between distance and displacement, speed and velocity, whether it is scalar or vectors quantity. Today, we are going to discuss how to describe these kinematics in motion in the form of a graph. Okay guys, now let's check your textbook page 7. We are going to discuss about the graph in kinematics. So before you see this displacement time graph, you need to bear in mind that the graph in kinematics and also many kind of graphs also, you need to see first what is in x-axis and also what is in y-axis. Here, the y-axis is for the displacement and the x-axis is for the time taken by the object that is moving. But somehow, in questions that you will face later, here, the y-axis can be velocity and also the x-axis can be time. Or maybe this one acceleration, this one is time. So you need to remember to check first what is in x-axis and what is in y-axis before you decide your answer. Why I'm telling you this? Because in A-level questions, there are many questions about graph. You need to see the graph carefully. Okay, the first thing that you need to see from the graph is the components of the graph. Okay, the components of the graphs. So let us check the kind of graph that is provided here. Let us check the first graph, this one. Okay, as you can see here, the first graph, x-axis is the displacement and also the y-axis is displacement and x-axis is the time. Okay, here the straight line shows that the object's velocity is constant. As you see, the increase in displacement followed by the increase in time. So it means that the object's velocity is not changing here. There is no acceleration. Okay, now let us check the second graph. Here, the slope shows which object is moving faster. The steeper the slope, the greater the velocity. Okay, so in displacement time graph, if the slope of the graph is steeper, like this one, yeah, it means that the velocity of the object is high. More steeper, higher velocity. Lower, it means slower velocity. That is for the second graph. Now, let us check the third graph. Here, it's a flat line between the displacement and time. The slope of this graph is 0. The displacement is not changing. The displacement is not changing. It means there is no movement of the object over the time. It means what? It means the velocity of the object is 0 or the object is in stationary. You will find this kind of graph also later, but with here velocity and here the time. If the velocity is in y-axis and then after that this one is the time and the graph is flat like this one, it means that there is velocity, okay, but there is no acceleration. So you see the difference between the displacement time. If it is flat, then it means there is no velocity or the object is in stationary. But if it is between velocity and time, here the graph, yeah, then it means that there is velocity, but the acceleration is equal to 0, or what we call as constant acceleration. Next, we check here the fourth graph. The slope of this graph suddenly becomes negative. The object is moving back the way it came. Its velocity is negative after time t. So this one, for example, is for car or an object that is moving forward. Okay, and then after that, the object is moving back the way it came. Okay, after it moves forward, and then after that it will goes back. So the graph will looks like this one, because it will come back to its original position. Okay, somehow maybe, yeah, this object, the displacement can be 0 because it goes back to its original position. And the last one, this displacement time graph is curved. The slope is changing. This means that the object's velocity is changing. This is considered in chapter 2. So if between displacement and time graph you see a curved line like this, it means that is acceleration. Okay. If the line is curved upwards, okay, I'm going to show you like this. Okay, or the other way around, yeah. So it means difference again later. Okay, so we need to check and see and also analyze the graph properly. Okay, so to make you more understand, about this one, let us check the example here. They give you the graph between displacement and also time. Okay, displacement, this is the displacement and then this is the time. So the gradient of these two lines is the velocity. Okay, the gradient of these two lines is the velocity of the object. So remember, yeah, displacement time graph, the gradient is the velocity. There will be questions asking you that one also later. One more time, displacement and time graph, the gradient will be the velocity. If velocity time graph, the gradient will be the acceleration. Okay? With this one, just okay, common calculations. For velocity, velocity is equal to delta S over T. You have known that. Okay, now let's check your comprehension for today by doing the questions number 10, 11, and also 12. So let's see number 10. The displacement time sketch graph in figure 110 represents the journey of a bus. What does the graph tell you about the journey? Okay, so here you see going up, you see first, this is between displacement and time. Okay, so it means that the gradient is the velocity. So here you see the velocity is, yeah, it's increasing. And then after that, flat. What does it mean? After that, going up, flat again. After that, going up. Okay, so what does this graph means? Tell me and describe to me in a paragraph for this one. Number 11, sketch a displacement time graph to show your motion for the following event. You are walking at a constant speed across a field after jumping off a gate. After jumping off a gate. Okay, you are walking at a constant speed. It means like how are you going to describe your motion in displacement time graph? And then suddenly you see a ball and stop after you walking with constant speed, and then after that you stop. Your friend says there is no danger, so you walk on at a reduced constant speed. Reduce constant speed. Okay, it means what? It means the slope with the previous movement, the first movement, yeah, is lower. Yeah, the step is lower rather than the first movement. Okay, and then so you walk on reduced constant speed, and then the ball below, and you run back to the gate. You ran back to the gate. It means that this the gradient, yeah, the gradient will be steeper rather than even the first one. Okay. Explain how each section of the walk relates to a section of your graph. So after you make the graph, then you need to explain each section, whether you are having constant velocity, or you stop, or increasing velocity, okay, something like that. So after you make the graph, you need to describe. Number 12, table 1.4 shows that the displacement of a racing car at different times as it travels along a straight track during a speed trial. Determine the car's velocity and also draw a displacement time graph and use it to find the car's velocity. Okay, to determine the car's velocity, actually you can choose one of the displacement and time taken, yeah, as long as it is not zero, because this one, it means that the car is not yet moving. Okay, so you can choose any here, since there is no acceleration, so the result will be the same actually, yeah. There is acceleration, then you cannot do it. You need to use another formula later. And for 12b, draw a displacement time graph and use it to find the car's velocity. So after that, you need to make this kind of graph, yeah, the displacement time graph. Okay, set the displacement at 85, and then the time taken is 1 second, 170 meter, at 2 seconds, and so on. And then after that, you make the line that is connecting the dot. Yes, so that's it. Okay, I hope you can do it by yourself first. And if you still have questions, yes, you still can ask me. Try to do it by yourself. Okay, please do not cheat from your friends. I think that's all for today. Let's do the questions first, and then don't forget to submit to me via Google Class. Okay, guys? Thank you all for today. Bye-bye.